All right, lesson 3.3, angles of polygons. Oh, I forgot my mic again. I need to remember to do that. I'm not going to do it right now. Just a refresher real quick on your warm-ups. This is -7/8 times x. So in order to solve it, you're going to divide by -7/8 or flip the fraction and multiply to move it. And then down here, you would divide to move it over to the other side. Okay? You should have written your key vocabulary. If you haven't, pause the video and write it. All right, so somebody tell me, what is the definition of a regular polygon? Go ahead, Josh.
Wait a minute.
You just wrote it. Sydney?
It is a polygon in which all the sides and interior angles are congruent.
All of the sides and interior angles are congruent. So can you give me an example of a regular polygon real quick? Just a quick, easy one. Anybody? Okay, Samuel. A square. Very good. All the sides would be the same length and all the angles would be the same angle. Are there other regular polygons out there? Yes. It's just not, you don't think of them right off the top of your head. Elena?
A star.
A star could be a regular polygon. Not usually, because the angles are different. Because you have these pointy angles here, and then these 4 angles here, and not all of them are the same. So usually the only other regular polygon you're going to see is like a hexagon, sometimes a pentagon, but you'll see them. So a polygon, just a polygon, is a closed plane figure made up of 3 or more line segments that intersect only at their end points. So if you look at the sketches here, we have a triangle, we have an arrow, a block arrow, and a star, and you see how none of these lines are curved, and they all close at a point, at an end point. Okay, these are not polygons. Circles, ovals, anything round, curved lines would not be considered polygons. Why is this last one not a polygon? Yes?
It's 2 separate figures.
What?
It's 2 separate figures.
No, they're connected right here in the middle. Because the rule right here, they have to intersect only at their end points. Okay, this one intersects a whole nother section. Okay? All right, this is the big formula you need to have in your journals. You will be using that a lot today. The sum, use letter S, of the interior angle measures of a polygon with n number of sides is S equals n minus 2 times 180. This formula is going to help you find the measurements of all of the angles inside a polygon, no matter how many angles there are. So you need to know this. It's probably good if you could memorize it, but I don't know that I require it. So n minus 2 times 180. So let's look at example 1. Write this in your journals, if it ever loads. All right, so we're going to find the sum of the interior angle measures of the school crossing sign. How many sides are on this school crossing sign? 5. Does anybody know what type of shape that's called, Kerwin? Sam?
Pentagon?
It is a pentagon, like the Pentagon in the United States in Washington. 5-sided shape, pentagon. So we're going to use our formula, and we're going to plug in 5 where the n is. Put this in your journals. Okay? So 5-sided shape, we're going to say 5 minus 2. What's 5 minus 2? 3. So then we do 3 times 180.
540.
Which is 540. So the interior angles add up to 540 degrees. Very good. Any questions? All right, go do your try-its. There are 2 of them. All right, example 2, you're putting this in your journal. We're going to find the value of x. This is a polygon with multiple sides, lots of angles, and we're missing one, aren't we?
Yes.
Okay. Is there a formula out there that we can use to solve for the missing variable? Go ahead, Josh.
N minus 2
Yeah, we can use our sum of interior angles formula. How many sides does this polygon have? 7. Very good. So we're going to plug that in where the n goes. 7 minus 2 times 180 to find out how much all of these angles should add up to be. What's 7 minus 2? 5 times 180? 900. So now I can say this angle plus this angle plus this angle plus all of these angles plus x equal 900, right? Like so. So you add all those up, what do you get? 778. So 778 plus x should equal 900. So far, so good? How do we find x? Subtract 778 from the 900, and you get? Very good, 122. So the value of x is x equals 122. Any questions? All right, go your next set. 3, 4, all the way to 8. All right, so this is example 3. Integrating science. A cloud system discovered on Saturn is in the approximate shape of a regular hexagon. What does the word regular mean when it comes to polygons, Elena?
All the sides are congruent.
All the sides are congruent. Anything else, Camila? Camila, yep. All the interior angles. So all these interior angles and then all the sides. Those are all congruent to each other. Find the measure of each interior angle of the hexagon. So we really just need to find one angle, right? And then they're all the same. So this says the hexagon is about 15,000 miles across. Approximately 4 Earths can fit inside of it. So that's a whole lot bigger than it looks. So let's look at our hexagon. How many sides does it have? 6. So we're going to use our formula, which is? You had it. So where do we plug in our 6? Where the n goes. 6 minus 2 is? 4 times 180. Oh, they skipped. 720. Very good. How am I going to find the measure of the interior angles? Kerwin. Why are we going to divide by 6? You're right, but why? Because this is what kind of hexagon? Oh, I clicked. Regular, so all the angles are going to be the same. So if I just take the total of angles and divide it by the number of angles, I'll have what each one equals, right? Very good. You were right. I wanted to push you to see if you knew why. So 720 divided by 6 is? 120. So every single angle in this regular hexagon equals 120 degrees.
Yes.
Any questions? Not too bad. This is an easy lesson, I think.
Yes.
All right, you have 2 more, 9 and 10. So go finish those. I believe that's it. Yep, finish 9 and 10, and then you are done for the day. You have, well, we're going to go out to recess in about 1 minute. So if you don't finish those 2, that's fine. They're not due till Monday. Yes.